So this is the last section that is on our exam in a week. So we'll finish it and we'll review on Wednesday. So 11.2, independence. Independence. So what we're talking about here is a test for independence. That's a little bit different than a test for a good fit. What are we talking about? Well, basically, let me just jump to the data. Polygraph test. Those things work?
No. They say it works.
Do they say?
Yes.
I haven't read up much on it. But here's some data. We'll try to see. Here's how could you statistically test if polygraph tests work or not? It's a stats question, really. So here they have a bunch of subjects that took a polygraph test, and they found out later whether they were lying or not lying. So, did the subjects actually lie? 9 did not lie. 47 lied among those that said they lied. Do you see that? The polygraph test here said the subjects lied. And sure enough, 47 of them were lying, but 9 were not. So 9 people got a false reading there. 9 people were told by the polygraph machine they were lying, and they weren't. And then the next group, the polygraph machine said they did not lie, and sure enough, 25 were not lying. That was accurate. But 8 people were lying and got away with it. The polygraph machine said they weren't lying, and they got away with it. So the question for us, is that statistically strong evidence or not? Specifically, we're wondering is whether the polygraph machine says you're lying or not independent from whether you actually are lying or not. I don't know if that sentence made any sense. So in other words, if the polygraph machine really works, then these two variables depend upon one another. How about, let me put it to you this way. Does your grade on the next exam have anything to do with whether you study or not? Silly question. Of course it does, right? So if I was to make, so maybe I'll put it to you that way, and then we'll come back to this. What if I was to make a big graph, and I was to say, person number 1, person number 2, or here, let's just go A, B, C. Student A, student B, student C, and I was to say how much they studied, like how many hours of study they did. So maybe person A studied, we say people that studied for the exam 0 to 1 hour, or 1 to 2 hours, or 2 to 3 hours. I don't know if I'm making up a very good graph here. I don't know how to do this. Okay. How about I do it this way? How about I say number of hours of study down this way. So it could be 0 to 1, 1 to 2, 2 to 3, 3 to 4 for the exam. And over here I put, did they get an A or below an A? I'll just to make it simple. Well, I could do A and A, B, C, D, but I don't want to be that complex. Well, I'm probably being confusing, huh?
Yes. Yeah.
Is this clarifying? All right. A, B, C, D, or F. Okay. Would you expect that the hours you study have anything to do with the grade you get on the exam? Of course. You would say that the hours of studying for the exam and grade on the exam, those two variables, those things vary, don't they? The hours you study for the exam is going to be different for different people, and the grade you get on the exam is going to be different for different people. Those are two variables. Those two variables depend upon one another. They have something to do with one another. They affect one another. Versus if I said, hey, how many hours did you spend exercising the week before the exam? And your grade on the exam probably have nothing to do with each other. Whether you exercised more or less probably won't affect your grade at all. So those variables would be independent. Let me write that out. Hours of exercising and grade on the test. Those two variables are independent. They do not affect one another. Does that make sense? Like children. Children are dependent. They're on your tax return, you file them as dependents. Mine are all getting old and I can't claim them on my income tax anymore. I've only got a couple left I can claim on my income tax. When they get older, they're independent. You can't claim them on your income tax, right? Same kind of thing. So dependent, they affect one another. When they're young, they depend upon me. They get older, they don't. Independent. Same kind of thing with the variables. Does that make sense? So we would expect hours of studying and grades to depend on one another. They affect one another. If you do more hours of studying, your grade goes up. Less hours of studying, grade goes down. Whereas exercising and grades have nothing to do with one another, independent. That's what we're testing. We're testing if two variables are independent or dependent upon one another, whether they affect each other or don't.
That's correlation.
Yeah, it's kind of like correlation. It is. It's very much like correlation. Yeah, do they affect? Now, how do you know if two variables affect one another? Well, you would expect if they're independent, you would expect the numbers to not change much. What I mean is, if this is hours of studying, you would expect people that only studied a little bit would get lower grades. Maybe there'd be 3 people that got C's, 2 got D's, 1 got an F. But among those that studied 1 to 2 hours, you'd expect more to get C's and B's. People that study more, probably more B's and A's. Those that did that, maybe all got A's. I don't know, I'm just making up numbers. But you get the idea. They're going to be different, aren't they? You'd expect the numbers to be different for different hours of studying. And so if they're different, that tells you that the hours of studying has an effect. It makes the grades different. They depend on one another. Whereas, if I did hours of exercise, what if I did hours of exercise and then grades? Well, it wouldn't be 0. I mean, you'd have some people that exercised only a little bit would get A's, some would get B's, some would get C's, D's, and F's. You might have 2 in each category, let's say. I'm just guessing. And you might have 2 in each category here. What you would have is numbers that are basically the same, I'm saying. I mean, of course, slight differences, but basically the same because it's not affecting it. Do you see what I mean? If 2 variables are independent, not affecting each other, then you would expect the categories to come out about the same, pretty close to the same. That means it has nothing to do with it. Exercising more doesn't change the way the grades. People that exercise more have the same kind of grades as people who exercise less. That means they're independent. They don't change one another. Okay, so let's go back here then. So what they're asking is for this polygraph test. If the polygraph test had no ability to determine if people were really lying or not, then we would expect these percentages to be the same, wouldn't we? What if I said, hey, I have a new way of telling if people are lying or not. If they click their teeth, they're lying. That's bogus. I'm just making up something dumb. If they click their teeth, they're lying. And if I used my little test and did my little thing, we would find out that that is not right. Those are independent. And the way we would find that out is these percentages would come out the same. There'd be this and this, this and this. They'd all be the same because whether you click your teeth or not has nothing to do with whether you're lying or not, probably. So I don't know if I'm making much sense out of this. So, but we better move forward. Let me give you the actual ways to test this. So it's pretty easy. It's going to be easier than the last section. So let's read this question. So basically they want me to test about the polygraph machine. The null hypothesis, we're in 11.2, independence. So let me make this as easy as I can. That is my job. So in 11.1, we were testing goodness of fit. The null was fit. Now we're in 11.2, we're testing independence. Guess what the null is going to be? Independence. It's going to be the same word, in other words. I'm telling you the title of the section is the null for both 11.1 and 11.2. The title of the section is the null for 11.1 and 11.2. So back in 11.1, the title of the section was good fit. The null was good fit. Now the title of the section is independence. The null is independent. The two variables are independent. And H1, what's the opposite of being independent? Dependent, right? So if the variables are either independent, which means they do not affect each other, and dependent, they do affect each other. Is that okay? Mm-hmm. So independent, like when a child is independent, he's not dependent on his parents' income anymore. He's independent. If I suddenly got rich, it would have no effect on my children that are out of the house, no matter how much they want it to have an effect. No, I'm just kidding. So independent, and then dependent, it affects it, right? Okay, so HO. Whether a subject lies is independent. Yeah, that's it. See, it's C. Independent. HO is independent. All right, let's take our calculator out. Now, y'all have your calculator? Mm-hmm. I know you do. That was a dumb question. Let's take our calculator. We're going to need to put this in like a matrix. Something we've never done before. Something new. Let me go over here and write it out for you. So in 11.2, test for independence, the matrix that we're going to put in, here's what you do on your calculator. You hit second matrix. That button is right above the x to the minus 1 key on the left. It's on the left side. It has a matrix. Hit second matrix.
Second and then matrix?
Second and then matrix. And you'll get a matrix submenu which shows three submenus: names, math, and edit. Are you getting that?
Yep.
Go over to edit and hit enter. And then you type 2 by 2 right at the top. 2 enter, 2 enter. And then you put in the 2 by 2 matrix that they gave us right here. 947, 25, 8. 947, 25. You just put in the matrix that they gave us. When you're done, you hit second, quit. The quit button is right above the mode key at the top. Quit, yeah, which is right above the mode key at the top. It's got that matrix stored in slot A automatically for you. Now you just hit stat, go over to the tests. I would go down to roll over the bottom of the screen to chi-square. So not goodness of fit, just chi-square test straight. Not the GOF, just the chi-square straight. Hit enter. Enter, enter, enter. It should have A and B already in there. And just hit enter. And I'm getting my answers. Yeah, hit calculate, yeah. My chi-square is 31.333, I guess. And my p-value is 2. Oh, you're right. 2.17, but I get e to the minus 8. So that decimal's going back 8 places. So, yeah, that's just going to be 4 zeros. What? 7 zeros. What? A bunch of zeros, right? You guys able to get that? On the calculator, is that coming out? You get that matrix in there okay? So, p is low. The null must go. So we reject the null. What was the null? What is the null always? We reject independence. We believe dependence. There's weak evidence for dependence. So we believe those variables are dependent upon one another, which means they affect one another, don't they? So let's see where we go. There is not sufficient, right? There's weak evidence to warrant rejection of the claim that polygraph testing is accurate. That whether a subject lies is independent of the polygraph test. Yeah, it's C. That's what we could not reject, independence. So does that mean we believe the thing works or doesn't work? Well, it's weak evidence, but we still concluded something. Which way did we conclude? Didn't we conclude that they're dependent?
Wait, we reject the null.
Yeah, we rejected the null. So we rejected independence. Remember, the null is the name of the section. So we believed dependence weakly, but we still believed dependence, which means what? Which means we believe that whether the person lied or not does have something to do with how they did on the polygraph test. We believe the polygraph test is doing something. It's not always perfect, but it's doing something. It's not like doing nothing. Right? They're dependent. If you fail the polygraph test, there's a better chance you're lying. Right? Is what that's saying. It's not strong evidence, it's weak. But it is still something. How we doing? Here's a civil servant exam. And we're wondering, is there evidence to support the claim that the results are discriminatory? So white candidates versus minority candidates, passed and failed. So we're trying to use this data to figure out if being white or not white has an effect on passing and failing this exam. So we're wondering, are those independent or dependent? So the null hypothesis is always the name of the section. Independent. And the alternative hypothesis is dependent. So, what does it mean again if two variables are independent? What does that mean? They don't rely on each other. They don't have anything to do with each other. They don't affect each other. No effect upon each other, right? Whereas dependent means they do affect each other. They depend upon one another. Right, okay, so here we go. So which one's the right null? White and minority candidates do not have the same chance. No. A white candidate is more likely. No. A white candidate is not more. No. White and minority have the same chance of passing the test. Is that right? Is that what the null? If this turns out to be independent, then that would mean whether you're white or not has no effect. So yes, that's what they're saying, huh? White and minority have the same chance, no effect. That's what independent. If we end up concluding independent, that's what that would mean, no effect. Whether you're white or not white, no effect. independent. All right. So why don't you just put that matrix in? This will be quicker than the last section. Just pop that matrix in there. So 20, 14, 8, 28. Put that in, that matrix. Second matrix. Go over to edit. Put in the 2 by 2. And then quit. And then do the stat test.
So it should have been 0.000. Now, what's after the 3?
I got 9.76.
Yep.
But how many want 3 places? 9.760. And the p-value? Yeah, 0017. Oh, 18. I guess round it to 18. All right, is that p low?
Yes.
Yes, p is low. So the p is low. HO must go. Reject the null. So we believe there's strong evidence that it depends. So there's strong evidence. P is low, reject the null. Strong evidence that it depends, affects. So let's answer the question there. There is sufficient evidence to reject the claim that Y candidate is more likely. No, that was never the claim. So we believe that they depend upon one another, they affect one another. And so that's D. There is sufficient evidence to support the claim that the results are discriminatory because they affect one another, right? There was an effect from the test. Whether you're white or not affected your score dependent. How we doing? We good? You feel like you could do this section?
You have to.
The rest is saying, Leonardo.
Is that all